Hi world, I'm Michelle with the Knowledge Commons, and this is the very first demo for the Open Data Explorer, an app I created that hopefully makes it fun and interesting to navigate and understand open data that is available out there on the World Wide Web in semantic web standards format for any human or machine to query because it's a publicly accessible resource. Pretty cool. Today's topic, the very first topic, is astronomy. I chose this topic because it's the topic of the default graph in OpenDataDEx, and it's also the visual theme of the app, so a good first topic. All right, let's get into it. The app is behind me here. Go to OpenDataDEx. This is what you should see, and so this is the graph that's already been made and generated. You can of course generate new ones, write custom queries, generate your own, but this is the default graph, and it is astronomy theme. Specifically, it's Wikipedia pages on all items in the Unified Astronomy Thesaurus, which is another open data source, but we are pulling from WikiData, from their SPARQL endpoint. SPARQL's a semantic web query language. And this is the exact query being sent to that endpoint to get this data, and we end up navigating 860 objects, where the objects are these clickable nodes, and then using 8,921 tags, where a tag is a property value pair. We can look at those tags by clicking on an edge, and we can see, for example, here, galaxy cluster, galaxy group has some shared tags where the exact property value for both. Similar tags, only the property is shared, values are different. And then unique tags where the property only belongs to one of the nodes. And then we can click on nodes and the Wikipedia page will pop up where we can learn more about the item, and we can navigate through, just get into weird parts of the graph. We can also, right now it's showing the 6 objects most related to that object. We can go higher, all the way to 12, and then very useful, let's say lunar crater, we want to see the top 1. Here's the top 3 objects related to it, and the top 1, lunar mare. So that makes sense with lunar crater. If we were to view the tags, we can see the only one that's shared is they're both on the moon, which is pretty important. And then they've got a few similar tags and then a few unique tags. So what we can see is there's really not much data on these. I bet moon has a lot more data. Yes, we can see moon has a lot more data belonging to it. The top object related to moon is Earth. That's great. And then I guess Venus and Earth are very closely related. Again, this is not because of some ontology, hierarchy, or taxonomy. This isn't being manually connected. This is just what the WikiData is showing, and OpenDataDEx is determining connections, clusters, relatedness based on that data. So let's see between Earth and Venus. We can see they're both described by the same sources. So there's a lot of metadata that's the same, both on the same Wikimedia important lists. So yeah, as far as like real data, that non-metadata, we've got this epoch, we've got parent astronomical body, location inner solar system, okay, and then a bunch of similar tags. So that makes sense. They both have child astronomical bodies. Let's see what Earth's child astronomical body is considered to be. Oh, it's got different orbits. Interesting. And then down at the very bottom, we've got some unique tags. Oh, that was Venus's. Oh, okay. So child astronomical body. Wow, these must all, a bunch of these must be satellites or something. And then, yeah, we've got unique tags. And then, yeah, we can see Earth, very rich, a good amount of data. Honestly, I'd expect more, but this is pretty good. But, you know, if we can always go back to the hub object, and which our entry point, the galaxy cluster, and there's only 8,921 tags for 860 objects. That's only about 100 tags per object. That's really not that much data. So I would say that astronomy data in WikiData could use a lot of work. I bet that data is available at other open data sources. It just has not been imported into WikiData yet. Or maybe it doesn't need to be, and I just need to look somewhere else for that astronomy data. Maybe somewhere at like the Unified Astronomy Thesaurus. One thing I really like about this query, this data set, is that there's a lot of different types of objects all within the same knowledge graph. You know, we've got Earth, Saturn, you know, very specific asteroids, things like that, actual tangible items in space, instances of classes. But then we also have very general phenomenon like gravity, black hole. We've got phenomenon like general relativity, and yeah, classes of objects, such as asteroid, you know, and so I like that they're all kind of mixed together, and OpenDataDEx has to find the connections between everything. So let's go back to our hub object. Note that you can search for objects. Let's look at the Andromeda galaxy here. We can see the top 12 related to it all the way to the top 1, which that's great. That makes sense why those are so related. We can see the tags that are related. We can go back to our previous object, and then we can, of course, return to our hub object. And the default number of relatedness is 6. I find that always gives you a pretty good, good-looking subset of the knowledge graph. Well, I mean, there's so much to learn and see here, so many different patterns, connections, you know, and then just learn, you know, some of the stuff I would love to know more about. But let's look at one other thing. We're going to search for metric, and we should get a couple of these things that are more mathematical astrophysics concept. And we can see these two don't share any exact property values, but they do have these similar tags, the main one being this defining formula. I'm guessing and they're both in defining formulas, so that's really connecting those two. So even though there's really not much data, like, yeah, that's it. OpenDataDEx was able to find a strong connection between those two, so that's great. And then, yeah, we have all these different theorems. This theorem is radiative flux. So I might expect, yeah, what it's related to. Let's see, the Schwarzschild. solution to Einstein's field equations, semi-minor axis. So yeah, we're getting into some weird things. But then, yeah, eventually it goes back to like a planet, such as that. So yeah, there's a lot to explore. I think the big thing with this data set is because a lot of data is lacking, you're going to see some weird connections, but I think they're interesting, and it makes it fun to click on these edges and see, okay, why are those related, and to see, oh, okay, they're metadata heavy maybe, rather than real data heavy, which is why they should be be linked. But you know, the fact that they're both described by the same source, that is an interesting connection too. So yeah, I think at this point, let's go into looking at the query. So with WikiData, it makes it really nice. They have a query service that we'll just quickly put this into. Let's see. Note that this middle section, if you were to customize or write a custom query, and anyone watching this is welcome to use this editor key, Ariadne. Please read the notes. That only the middle section here is editable. This beginning part is required, and then this limit down here is also required. So let's just run that. And while it's running, this is the most important line right here. This is saying we want all items that have the property unified astronomy thesaurus ID, and doesn't matter what that ID is. And then we're getting all this data. Some of those triples are the constructed triples here. And then this is to get like good properties and values. This is to say we want the Wikipedia page instead of the entity's URI. So this is the most important part. So why did I choose that? Well, I chose that because I was trying to get a good subset of objects, and it was surprisingly hard to do with astronomy data. I was trying lots of different things. I tried to do all items that had like let's see, what exactly was it again? A child astronomical body 398. But I think that there's so much of this data that WikiData ends up just churning and churning and eventually times out. So then I was like, okay, if it has both a child and a parent astronomical body, then maybe that'll narrow things down. But unfortunately, that same thing, it just churns and churns, eventually times out. So yeah, it was it was surprisingly hard to do, you know. A good way, if you're wanting to know, if you go to the Wikipedia page under Tools and go to WikiData item, you can see all the data. Again, you can also just click on the tags, and you know, this data is the same data you'll see in there. But that's a good way to see, okay, which of these can I use, studied by astrophysics, studied, you know, has schematics. What's the best way to get a good subset of data? And it turns out either a lot of the data is incomplete, or there's too much, or the query, it can't find an optimized query to get it. So you see here this timed out. So fortunately, someone has entered this unified astronomy thesaurus ID for a lot of astronomy objects and gave me that nice number of 860 objects that the query service doesn't time out giving me. So that's why that was chosen, and I really like it because it does give me that variety of types of objects that you don't usually see in navigatable knowledge graphs. All right, there's so much more to say, but if you have any questions, please just comment or send me an email. You can go to theknowledgecommons.org here. Take a look around, send me an email here, info@theknowledgecommons.org, and let me know what you would like to know more about. I'm happy to share. My hope is that I empower people and communities to cultivate information as a shared resource. Thank you everyone for watching, and I will see you for next week's topic.